Hello everyone. I hope I am live. Yep, I guess I am. So hello everyone and welcome to a new Comet live stream. This is like a little bit out of the blue. I didn't plan to actually go live today, but I had a little bit of time on my hand. Since I haven't worked on the project since last time I streamed, I thought it was a good idea. So yeah, so today on the agenda we have we need support for arrays, and I want to review a couple of issues and a pull request that is made by a new contributor, which is Anwar. I wanted to say thank you for contributing to the project with your PR and your issues, and I wanna like say for everyone who wants to contribute, you are more than welcome. So Anwar tried a couple of assignments, and like he saw that even we are declaring a and twice, this works, and he thought that this should be probably an error, and I argued since we don't have a formal spec on the current project, I would say that just leave it be. Maybe the best thing that we can do for now, since we don't have a formal language specification, is say that a is like print out an error when actually interpreting, and then saying, hey, you have a variable declaration a that is shadowing a variable declaration before it. So I will leave the issue open until next time, or at least we have a formal language definition. He also kind of found the bug with printf, which I don't have any tests for printf built-in function. When trying to add arguments or like doing escape sequences, apparently it's reading escaped char sequences separately, which is a little bit bad. And also we are not properly formatting arguments, like we are not expanding the arguments that we get, which is also not nice. I guess he has a pull request for this as well. So I already reviewed the PR. It was a small change, but I requested a little bit of I don't know if he changed. I requested a test to actually formulate this. He wrote a couple. So he wrote this, and then he wrote printf, and then he created a new evaluator, and he parsed and then evaluated, but all right. So I suppose he doesn't go well enough to actually write tests for this. I guess it's fine. We can like improve on this later on. Yeah, I guess this can be improved, and we need to somehow to make printf enable input/output capturing in tests. I don't think it's gonna be too hard to do, but yeah. In the meantime, I'll leave the PR open until I figure out like how can we do this. If we have until we add at least the ability to capture input and output in tests, since we don't have this feature, and I don't expect anyone actually writing a fix for that bug to write support for this. It doesn't make a lot of sense. Right. Right. So today we want to open the project, since I haven't opened it since last time. Sure. So let me close this up because we won't be needing it right now. And for some reason, oh yeah, so this is still getting printed the way I wanted to. For the people watching, if the font is too small, please tell me so I can bump it up. Otherwise, I will continue like this. All right. So last time we made updates on evaluation and all, but for this time I want to have array support. And array support is as defined by the README file. I want to be able to do this. Variable, array, some name, and then I want to be able to parse these expressions and then assign them to a variable. So the array can be empty as well, and we can handle arrays in a very specific manner, such that we represent arrays like as strings and integers and longs as primitive types to the comment language. So we would expect to have a comment array. All right. Now, arrays should be mutable and should like expose a method or to call on them so that we can add values to it. So array values that push, what you'd expect is to add some given value, but we don't have object support and we don't have call methods on object yet. So until that is implemented, I guess we can go ahead and start like just having syntax nodes for this and like parsing it as well. And once we have this, like we can add support for other primitive objects, like the ones such as here. And once we add support for this and being able to call methods on this, we will like make the link between objects that are declared using the new keyword and arrays as well. Yeah. If anybody has any comments on this, feel free. But I guess I will go for this like this. It makes sense in my opinion. And again, I'm operating like without having any formal specification for the language, and I'm not gonna make one for now since we're just exploring. So yeah, I guess we go back to Mosh, master. I guess I should be pulled in. Oh, get dust should work. All right. Well, we have the latest version of the code. I should probably check out a new version. Feature array parsing, and then let's start from there. So as any of the other things that we did with the parser, as like we started with creating whatever we wanted to create, such as tests or nodes, and then we created the parsing logic, and then we made sure that the tests actually pass. And then to test the actual nodes, we created a structure that is called a tree, a visitor, so to say. And that visitor should have the DFS order of the tree. And then we assert that the DFS order or the tree visiting order is kind of the same as the one that we'd expect. This is not 100% correct for all trees, but I guess it's good enough. So for parsing arrays, we would need to do the same thing, basically. So I'll come in here and then like, this file needs a little bit of cleanup, but we will do it and whenever I had the time to actually do this. So I will have a an array expression, an array declaration expression. No, an array expression actually. A struct. When I implement expression, right? The receiver type is an array expression, and for the literal, so every array expression we wanted to have I'm not sure, do we want the length? I don't think the length is on the Yeah, so we'll have a bunch of expressions. I'm gonna say that's what actually makes sense. Elements. And those are the elements of the array. And for the literal, well, for now we don't use it much. We have an implementation of a literal in here. Yeah, I'll just return an array, and then just say array with the given length. Yep. And for the visitor, we want the visitor dot visit array expression, and I want to give it a. At least I want to create this. All right. We have a visitor sign. This should be. I feel like this should be an array. Visit array literal, because in fact that's what it is. It's array literal. Yep, I want to refactor the type. Hopefully this gets picked up. Cool. So yeah. All right, now we have this. I guess a bunch of stuff will break, like in the testing visitor should implement, should add the support for node visitor, I guess is the node array. And to actually test the array literal, we need to go like where I need to find other literals to actually do the same. A binary number literal, that'd be nice. So we should do whatever we did before, and current array literal. We want an array literal, and then we say search.to t.t. Okay. And the search.equal t.t len of. Now we don't want to do this. What we want to do is to visit the array literal. It's children, I guess. So what we want to do is array dot elements dot for we want to do t dot visit expression, and then we give it the expression. That would make a lot more sense. But yeah, not array dot element current array literal. Yep. We don't care about this that much. We only care about this, that we want this to be called like this. Yep. So this kind of fixes whatever is broken in here. I'm not sure if anything is broken somewhere else. I'll try to build it. Yep, something else is broken. And the debug printer. All right, so the printer in the debug should have the same thing. Implement node visitor, and this should be like what you'd expect as p.printIndent, p.buffer dot Alright. Alright, string. Say int an array. Yeah, a good idea would be like to say just array dot literal. And then we do array dot elements dot for say element. We go with the b dot visit expression of real. This should fix the issue. Right. It should help us debug this later on. Now we should expect everything to pass. Now it's built in without any problems. And we want to add our tests. So I will shamelessly copy some of the stuff that we had, and I want to test parse array literal, and we want to have an expression which is a string, and yeah, and all right, and then I need a couple of nodes, so I want to have this as my first test, and I want to say like the first node that I'll be finding is like an array literal node. And I guess that's it. Yeah, seems looks good. So probably running this would blow up, right? Oh, it passed. So something is not wrong. Is not right, because this test passes. So we parse. Something is not correct. Huh. How do we visit array literal? So we make sure that the current node, no, it's not the expected. Come on. I'm kind of doubting what I was doing before. Something feels off. So the current node is where is we expecting, and the array literal. So we did a cast to make sure that the current node is something, but yeah, something feels off. Let me make sure of this. Let me create a breakpoint in a debug in here and make sure that we aren't doing anything stupid. So we create a root node, and then let me see what got compiled. The root node has 0 statements. Aha. So when it got in, we got into a root node, and for each statement we did an accept, and then we got out. Oh, I see. So we couldn't parse anything. The weird thing is, like, okay, so the parser kind of went in and then said parse statement, and we parse the statement, and when we couldn't find a statement to parse, there's a parse expression, and the parse internal, and then we, if not has, we have a p error report. Did we get to here? Because I'm sure we don't have any. All right, we reported the error and then we went back because I'm sure we don't have any function for this. All right, so we need to assert that the parser actually doesn't have any errors. Oh, so the parser errors that has any, so this should be false. This always should be false. Yeah, so now it has an error because we can't parse it. We know for sure that we can't parse this character. So let's go back to, we have functions for parsing, like, hello Edgeman, how's it going? Oh, so we have a lot of prefix functions, and we want to add probably a prefix function for this. What we're gonna do is p.register prefix function and p.parse array literal elixir dot open bracket, yeah. All right, so we don't have this function yet. I want to find parse string literal because I want to keep them like hidden in some place. So I'll find p parser parse array literal. So return an expression, and what we want to do is is make sure that the actual so we create an array equals an array literal. I feel like array literal is not following the convention that we took. So we have array string literal. All right, so all of them are literals. Okay. And then for the elements is kind of empty. So we should make a make expression outside of 0. Now, if p dot next token equals lexer dot type, lexer dot close, p dot advance, and return this in case of an empty array. If we have an empty array, we want to advance to the next token and then continue. Otherwise, we know that we have something. Yes, we know for sure that there are some elements to be consumed. And what we want to do is like while, so for p dot current token is different than so while we are not in the next token dot type is different than lexer dot close parent. So while that's not the case, we do p dot parse expression and then array dot append array dot elements to this array equals this, or at least array dot elements equals this. And then we want to make sure that p dot next token we have something like advance and expect. Yeah, p dot advance and expect. And expect lexer dot comma. Right? On the current token to be a comma. Alright, it's a comma only if it's, yeah, it's gonna be a comma unless this is the last element. So what we want to do is like we're not sure. So the next element is not. So we have something like this. So the first time we're going to parse x1, and then we have a comma, x2, we have a comma, x3, but when x3 is gonna be followed by something like this. But in fact, it's gonna be waiting for a comma. So if p dot next token dot type is equal to lexer dot close parent, close not parent but bracket. Yes, I do speak Arabic. But I'm not gonna speak Arabic in stream. But if you have questions in Arabic, feel free to ask them. I'll try to translate. So it's not a closed bracket, and this is not a closed bracket. Sure. Thank you for passing by. So if it's a all right, good luck. Thank you for passing by. So the next token type is so you were hoping for rather something Moroccan. Yeah, that could be nice. I guess I have a fork of this channel that would contain more Moroccan Arabic content, but in the main channel it's kind of always English. So yeah, feel free to subscribe to the other channel. when we have live streams there. But thank you. Yeah, I was doing something. Yeah. So it's not close bracket. Oh, that's kind of tricky. So if it's not a next token dot type dot lexer dot close bracket, let's break. We assume we terminated. Otherwise, I will do the advanced aspect call. Yep. And here we should assume that we are at a close bracket and nothing is wrong. Thanks, Coco. All right. So we have this, and I assume we are at a close bracket. We should now add an advance. Make sure that we consume the current token, and then we return the P. Not P, but the array. But this needs to be debugged, of course. I have no intention of this working from the first time. All right, so we came in here, we created the literal, and then what's the next token of the P? So the next token is a close bracket. So this time it's gonna be a close bracket. I'll go return to the array. Oh, so this is a yeah, so I assume we probably, like, with the logic we implemented before, we should probably consume both of them. Yep. Let's do this. Consume the first open bracket. And then this becomes current token equals, and if that's the case, we consume it and then we go back, and this is an advance, and expect that the current token is lexer.open bracket. Otherwise, while I guess while the current token is not that type, so we, and then if the current token is not a close bracket, we break. Otherwise, we advance and expect that the current bracket is a comma. Otherwise, we are at the current token, and then we advance and expect that p dot the current token is close bracket. Yep, advance, expect. Cool. I guess this works. Maybe. All right, so we do this, and I guess we get out of the function very fast. We go back to prefix, we go back to parsing the expression, go back, and then get out. Let me see the root node generated. So the root node contains one statement, which is an array literal. Sweet. Now the test actually works. What I want to make sure is, like, what if we have something like after it, like something like this? Let's say we have a, let's say this is allowed in comment. Let's just suppose for the sake of the argument. I'll suppose that I'll have a binary expression. And I'll have an op. How did I test binary? How did I create? This is probably it. So I have a plus, and then I have a number literal expression, which is an actual value of 123. All right, now if we do the run into test, it would fail, which means, I have a nil pointer? When? Or at least where? Oh. The current number literal. So we want it to be the same. I guess we did this. I'm not sure why it failed. Let's do this again. This time let's block here. Yep. So let's see what's the root node that got generated. No statement. We got two statements. Oh, so the first one is an array literal, and the second one is an actual value, but there is no binary expression between them. Yeah, so this feels a little bit fishy. All right, let's see what actually gets. So when parsing the array literal, what happens? So I go in, we get out early, which is good in this case. The current precedence with the next token. What's the next token? So the current precedence is minimum, and the next token is oh, it's a 1, 2, 3. All right, so do we leave it? I don't remember whether we leave it in the first element or over the last element. Advance and expect current type. So do we have I guess we can do this. Let's try and leave it. Would this work now? I'm not gonna consume anything. Now the next token is a plus variable. Now what's the root node that got generated? Yeah, now we have one statement. It is a binary expression that contains an array literal with the number expression. Now it works, I guess. Yep. And when running, yep, it works. All right. Azos. Hey. All right. Now I should remove this because I know this is a bogus test. I just wanted to make sure that actually it works. Yeah. So let's do a 1, 2, 3. And we have an array literal and 3 number literal values. So number literal expressions. Yeah, I want an actual value. 1. right. So let's run this. It doesn't work. All right. Let's debug and see what happens. I'm gonna remove this, go back. The root node for this is one statement containing the array literal. All right, and the next time. Yep. Right. Now, why do we have this? I assume there is something wrong in yeah, something is wrong around here. So when we parse, the current token type is not this. All right. Yeah, I guess the bug is in here. Right. So let's go to the next one. Yeah. So the next one, the next time it happened, it's Lexer is yeah. The current token is so this is an open bracket. Let's see, does the array have any elements? Yes, it does. And the elements are 1. What does advance and expect? So the current token should be a comma, right? Yeah, so we already have an error in the error bag. I expected a comma, but got 1 instead. Yep. So what happens here is like this actually leaves yep. I should probably skip the next one. So what happens, or at least what I understood happens, is like we read read like the first expression, and then the cursor is here, and then when we get to this part, we skip, and the current token now is here. And this doesn't have another expression. So what can be done is maybe skipping twice would work. So we skip the comma. If we ever get to here, we know that we skip the parse expression, and then we need to kind of advance. And then the current token type should be a yeah, it should be a close bracket. Yeah, now the tests pass, because we want to advance and make sure that the current, if not the current is a closed test bracket, if we're not pointing at it, we should probably skip it. Now the test pass. So let's add a couple. Let's add one with strings in it, maybe. And let's have only one element stuff. It works. Let's add comment is nicer. Oh, wait a second. Why this worked? This shouldn't have worked. Oh, this is very wrong. We're asserting that the middle elements are number elements, which is not totally okay. Oh man, there is some form of bug in the tests. The worst thing is having not buggy code, but buggy tests. So where am I? Right, the first, the second, I guess it's the third. And I got in a array literal with one element, which is a string literal, and this worked. But when we go into the accept, something bad happens. All right. So the current node and the expected. So the expected, so the current node should be an array literal. The cast is okay. Do a T-pointer. Oh, right. I know what went wrong. This is wrong. Because it should be expression. I don't think that should have been the case. No. I'm not sure. We have an array literal. We are trying to cast the expected. Make sure that it's an array literal. Right. Yep. And this time we should do this. We only care that it's actually. If we do this now, this would break. Well, I assume it would break. It still doesn't break. Huh. Alright. So let's do this. Let's debug this. Put a breakpoint there. Yeah. So when we got to the array, we got elements with one array. That's nice. We did this, we did that. And then for each array element, we visited the expression. Yeah, visiting an expression doesn't do much. I'm not sure what I did there, but oh my god, sometimes I do the weirdest things. Yep, now it fails. Nice. And now let's do string literal. Value is comment. Now it passes. Let's see if this is the case for them. Okay, everything passes. Sweet. All right. Can we do arrays inside arrays? Oh, that's nice. I guess that's gonna be a nice test. Let's declare arrays inside arrays. So 1, 2, 3, 1, 2, 3. Let's not do all of them of the same size. 1. So the structure should be an array literal with 3 of them. Let's do 42, 43, 45. Let's do 42, 43, 44. All right. Cool. Hey, Zakaria. All right. Now it fails. And it fails with some trace. Let me make sure that I didn't break the test. Yeah, so the test looks all right. Okay, so let's see what broke. Okay, all right. So let me see what got generated. Did the correct syntax tree got generated? For some reason, I can't make a breakpoint. So this is the first, the second, the third. So we have an array literal with 3 elements, and each element is an array literal. This looks promising. Shedman is saying hi. Hi, Beck. And then a number expression, and then another. Oh, wait a second. Yeah, so we have 3 number expressions. And then another 3 number expressions. And then 1 number expression. All right. So the tree is okay, yet we are having problems. So let's make sure that the parser errors are not. So there are no errors in parsing. Actually, we have a bug in the test. Oh, I guess I know. Yep, we needed a first array literal. So the DFS order is like visit this array, and then the second array, which is this one, then 3 elements, and then this array, and then 3 elements, and then this array, and then 1 element. And this is the order. We were missing the outer one. Yep. All right. I'll make a commit in here, maybe. Could add. Let's say I have 1 deletion. Really? What did I delete? Oh, did I delete something? I'm not sure. It says that I deleted something, but I don't think I did. All right, chat is not doing anything. Okay, now I want to clean up a little bit of naming. So we have, I'm gonna remove kind of some weird names. We have an array literal, which is, so whenever we see a literal, it's a language primitive in common. So a string, but for number, I guess we did it differently. For some reason, I think number is different. and it's not grouped well with them. I'm missing some kind of. Yeah, so this one should be a number literal, and that's it. Shouldn't be more than this. And now it should not be here. It should be like a little bit down, like before string literals. That would be a great place to put it. Let me build and see. Go test. Okay, everything still passes. Do I need any more cleanup to do? So the parser's tests are getting a little bit big, so to say, but for the time being, we're gonna leave them. I don't want to break up the parser tests yet. Sweet. Now let's commit this, and then let's go to try and evaluate this. Git add, git commit, cleanup, naming, and put it literal. Cool. Yes, so now let's try to make this be interpreted. For now, if we go to our evaluator, he doesn't know anything about arrays. Yeah, so if I came in, I come in here, and then I will shamelessly again steal a test, and this time evaluate arrays, evaluate array declaration. We want to have a var a equals this, and the search function is like we want to find this and std array type, and it should be like comment array, and then it should be like value that we want to have an int of 0 val.length. Right, so we know this doesn't compile yet, so let's create it. So we go to std module, and we have built-ins. Let's do it right about here. Array type, and this is an array, and I want to have a comment func object error a string. Let's put it in here. Type comment array struct, and then let's have a length property, which is an int for now. And let's say that we want to implement a comment object. So the type array type, right? And the toString is whatever's concatenation of toString of all of its values. Yes, I guess that should be it. So for each comment array, we want to have a bunch of comment objects. So values. So you want to have a bunch of values in it. I should panic for now. I'll let it implement me later. Now we see that this actually compiles properly, and I don't think it will work. So So if we run this, we see that conversion std object is not an std comment array. We got a nope for some reason. Oh yeah, we got a nope. Yeah, that's weird. Like, evaluating this shouldn't be possible. Oh, but I guess since we don't know anything about this, probably a nope instance got generated. But well, if assert found in scope, it failed. I guess, yeah, just in here. And so what happened is that A was created in the local scope of the evaluator, and then it got assigned a value of null, a nope, because the evaluator, when creating a declaration statement, is gonna try and parse that the expression tree, try to evaluate it to actually assign it to A. Problem is, it couldn't know what's an array literal, and all it did was like return a nope instance. What we want to do is like add support for this. So here, down here, I'm gonna say like, hey parser dot array literal. Whenever we find an array literal, I guess like the end should have a bunch of elements. What we do is like we'll return like evaluate eval array elements. Right, and if we create this, excuse me, we'll create the evaluator array, which is like the comment object. So the array object is just a comment array, and the length property should be len of array dot elements, and then for each of those elements in the order of declaration, so array dot elements for I, array. So here we're gonna make a comment object, comment array, comment object, let's say. And we're gonna give it a length of length. So this is the array content. And for each one of those array elements, we want to have the array content of I equal to ev.eval the next element, which is the element. And then we can return an array, the array content. Not the array content, but the array. And the array, of course, that content, that values should be the array content. All right. If we run the test again, it should work. Cool. So let's do another thing. So now we didn't assert on the values. So now we don't have values. So let's try and make sure that Now var a is equal to whatever's value we give to it, and we want to find array. We want it to have 3 values, right? And we want the value of values. So I don't think it should be called value. It should be called array maybe. Now array dot values dot 0. We want to make sure that this is actually I want to assert on the type and I want to assert on the value. So I want to make sure that the actual, so let's say that assert true that type is equal to a cd dot int, right? And we need a t maybe, and then we assert for all of them. All right, do I have a utility method in here? Assert boolean, assert integer, right? And then we do an assert integer. I guess this on the value, right? Yeah, we do that t array dot values of 0, and the value is 1. Should say that no, I should remove this probably. And when running this actually still works. Cool. Then again, I should probably add one containing arrays of arrays. So we assert that a is in scope, a is 1, and the array length now is 2. And we do like, we want to make sure that the actual value, the array values dot 0, want to assert true, that is assert dot true, that the actual array of 0 is dot type is equal to array type, and that when casted, like when we do comment array, not t but array values of 0 to be casted to a comment array, I want to make sure that it actually assert that it has a length of 0, which is 2 0 array value of 0 dot length, right? And we want to do probably the same thing for the second type, although this is a little bit messy, but for one want to have a length of 2, and we want to assert integers that array value of 1, values of 0, all right. Okay, I messed up this. You expected something to have 2 and it has 0. Oh no, this is not good. This value here is 2. All right. So this is still broken. Where exactly? All right. So the array is 0 of 1, of course, should have 2 elements, and this still works. So I guess we can say but we are pretty sure that this is actually working. Maybe another test, just to be completely sure that whatever we did on the parser actually still works. 42. So we have a 2 elements, right? And this is not cool. We do a search str t and then say array at values of 0. Let's say comment, and 1 it's 42. 42, right? So we need to create a I don't think we have it. We'll copy it from here. So I have a comment object and the expected, which is string. I cast it to a comment string, make sure it's true. All right, this still works. Good. So one might ask, what if we have values of multiple types, like having integers, strings, arrays on the same array? For this, I would say, I don't know. We don't have a language specification that says whether this is possible or not. Some languages allow this, some languages don't. I don't really have a strong opinion about this, since I don't have any strong type system in place. So I'm neither against it nor for it. So I'll need to kind of think about it more and see what makes sense for the language. Yeah. I guess for this ECS, what is the local history and do a git commit. Let me commit the files I updated. Add array literal evaluation declaration only, because we didn't test anything else. So let me commit this at first, and I needed to make this string version for the REPL to work. So if I do go on main, I go, and I create the REPL, I can do like a var a equals but whenever I do a, we'll panic because we don't have any string implementation. So let's do this. Types maybe, yeah, types, and the 2 string for the array. So I don't know, is it buffer? Maybe it's called buffer. Buffer, maybe. Yeah, I can write strings to it. So above that write string, I want to write this and do for c.values. Therefore, I'm gonna say if I is bigger than 0. In that case, we do buff.write string. We write the separator. Otherwise, we write we do buff.write string. Expression or object. Object is so the object toString. And whenever we finish, we should write string that be closed. And then we return a buff.string. Maybe this is correct. So var I equals something like this, and then if we say a, we say a comment int 1, 2, 3, 4. We do the same for s equals some strings. And we do s. This still applies, right? And we do scope. We have 2 arrays, which is what you'd expect, and we exit. I'll add a new commit for this, and I'll push the changes to the new branch so you can check them out in the new branch. And if you guys don't have any questions, I guess I'll leave it till next time. I'll be ending the stream in a couple of minutes, so if you don't have any, okay. Apparently I'm not logged into GitHub from here. Can I do via command line? Git status, git push, git push. Let's see. I got a U origin feature array parsing. Yeah, I'm not logged in. Cool. I can push it after the stream finishes. If you don't have any questions, thank you for watching, and I guess I'll see you in the next stream. Feel free to actually reach out and send me messages or tweets or whatever your favorite manner of communication is about this, and feel free to create issues or pull requests to the language. Whenever you create a pull request, I will actually review it in the next stream and merge it by then. Until the next one then. See you guys.